Hello everyone, I am Sriyasha studying computer science and engineering on Vijnana Bharati Institute of Technology. Today I am here to give a seminar on waterfall model in software engineering. Now let's see introduction to software engineering models. What is software engineering? Software engineering is the systematic approach to designing, developing, testing and maintaining software. It ensures software is high quality, reliable, cost effective and scalable. What are software engineering models? Software engineering models define a structured approach to software development. They help in planning, execution, and management of software projects efficiently. Now, let's see why do we use software engineering models for organized process, predictability, risk reduction, quality assurance, efficient resource utilization. Now, let's see organized process. Let's talk about the organized process. It avoids confusion and mismanagement. And second one, predictability helps estimate time, cost, and effect. And risk. Now let's see risk reduction. Identifies potential issues early. Fourth one, quality assurance. Ensures systematic testing and validation. Fifth one, efficient resource utilization. With proper planning, it has proper planning leads to better time and cost management. Now let's see overview of the waterfall model. The waterfall model is one of the oldest and most traditional software development methodologies. It was first introduced by Vincent W. Royce in 1970. What is the waterfall model? Now let's see what is the waterfall model. The waterfall model follows in a linear and sequential process, meaning each phase must be completed before the next begins. There is no overlapping or going back to previous phases. Why is it called waterfall model? Just like a waterfall, the development process flows in one direction only, from the top to the bottom. This model is best for small to medium sized projects where requirements are fixed and well defined. Now let's see phases of the waterfall model. There are Waterfall consists of six main phases. The six main phases are requirement analysis, system design, implementation, testing, deployment, maintenance. These are the six important phases. Now let's talk about the requirement analysis. It gather all requirements from stakeholders. It activities are interviews with the clients and users, create the software requirement specification document, define system functionalities and constraints. Now let's talk about the system design. Its goal is to convert requirement into an architectural design. Its activities are define system architecture and components. It chooses programming languages, databases, and frameworks. It designs UI UX database schema and data flow diagrams. Now let's talk about implementation. Its goal is to write the actual code based on design. Its activities are developers write, compile, and integrate the code, follows coding standards and best practices, conduct conducts unit testing and at the code level. Now let's talk about the testing. It ensures the software meets all requirements, is free from defects. Its activities are performs different types of testing. There are There are four types of testing. One is unit testing, interrogations testing, system testing, user acceptance testing. Now let's talk about the unit testing. Unit testing, it tests individual components. Second one, interrogation testing. It checks how modules work together. Third one, system testing. It validates the entire system. Fourth one, acceptance testing. It ensures the software meets clients. Log fix defects before deployment. Now let's talk about the deployment. Its goal is to release the final software to users. Its activities are install the software on user systems or cloud servers, conduct beta testing if required, provide user manual and training. Now let's talk about the maintenance. Its goal is to provide long-term support and updates. Types of maintenance. There are three types of maintenance. One is corrective maintenance, adaptive maintenance, perfective maintenance. These are the three types of maintenance. Now let's talk about the corrective maintenance. It fixes bugs and errors. Now let's talk about the adaptive maintenance. Adaptive maintenance modifies software for new environments. Third one, perfective maintenance. Perfective maintenance adds new features and improves performance. Now let's talk about the advantages and disadvantages of the waterfall model. First, we will talk about advantages of the waterfall model. It is simple and easy to use. Each phase has a very defined start and end. Clear documentation, requirements, design, and code are well documented. System testing. Testing happens after full development. Better for small projects. Works well when requirements are well known. Time and cost predictability. Budgeting is easier due to structured phases. Now let's see disadvantages of the waterfall model. Inflexible, inflexible does not allow changes once development starts. Late testing, bugs are detected in later stages makes them costly to fix. Risky for large projects. If the requirements are incorrect, the entire project can fail. No customer feedback is developed in development. Users see the final product only after completion, not suitable for complex and evolving requirements. Now let's see the comparison between waterfall model versus other models. First, waterfall model. Sequential approach, low flexibility, low customer involvement. After development, testing phase is after development. Poor risk handling. Best for small, well-defined projects. Now let's talk about the agile model. Approach is iterative and incremental, high flexibility, high customer involvement, continuous testing, risk, good risk handling, best for rapid changes and evolvement requirements. Now let's talk about the spiral model. A risk-driven approach, medium flexibility, medium customer involvement, frequent testing, excellent risk handling. So, best for high-risk projects. Now let's talk about the V model. Parallel testing and development, moderate flexibility, low customer involvement, alongside development testing phase, moderate risk handling, best for critical systems. Example like medical, aerospace. And now let's see when to use waterfall model and when not to use waterfall model. First of all, we'll see when to use waterfall model. The waterfall model is best for projects with fixed requirements, no major changes expected. Well documented projects, government, military, banking system. Small to medium projects, simple applications with a clear scope. Stable technologies where technology is well understood. Now let's see when not to use the waterfall model. For large complex projects, requirements evolve over time. For fast-paced environments, waterfall is too slow for rapid changes. For customer-driven development, agile is better for frequent feedback. For high-risk projects, spiral model handles risk better. Now let's see the conclusion. The waterfall model is a traditional structure and a sequential software development approach. It is best suited for small projects with fixed requirements, but not ideal for dynamic or complex projects. Modern methodologies like Agile and Spiral have replaced waterfall most large scale and evolving projects. However, waterfall is still useful and industries requiring strict documentation and regularity compliance such as healthcare, banking, and defense. Now let's talk about the frequently asked questions about waterfall model or software engineering models. First question: is the waterfall model still used today? Yes, but mainly in projects with strict requirements. such as government or safety critical systems. Second question, why is the waterfall model not suitable for modern software development? Because it does not handle changing requirements well, leading to inefficiencies. Third question, what is the biggest drawback of the waterfall model? The biggest drawback is lack of flexibility. Changes cannot be easily accommodated once development starts. Thank you.